Good morning, my friends. Welcome to another episode of Xa Talk Show. And we are going to show you today one of the most idiotic thing in programming industry standards. So I'm going to wait a little bit for people to come on. So meanwhile, I'm going to uh, I'm going to do a little screenshot. So what I'm going to show you is this SVG path, elliptical path. And let's see. Let's do a screenshot. Okay, hold on a second. Now I'm going to show you why this is the most idiotic thing in the programming industry. I'm going to talk about why, in programming industry, if you are a programmer and if you have, let's say, 10 years experience, you've been there. Well, I guess most of you are not there because experienced programmers usually they don't go online and watch stuff. Anyway, so the if you are a programmer, you've been in the industry for a while, you know that every day you have programming languages, protocols, standards. They are often the most idiotic. Lots of problems and issues. And the reason, I've been programming for over 20 years, and the reason, so I realized in recent years, the reason is that it's just because corporations, um, and I realized that it's likely that programming languages or protocols they will never be clean. Usually, okay, this is not all because, for example, Golang is pretty good. JavaScript is extremely bad. The web technologies are extremely bad. HTML, CSS are fairly lousy, extremely bad, especially HTML5. Um, you know, and also if you program in C, Unix, Linux, they are extremely bad. Like so like you see programmers complain all the time, and you see, like you go to Stack Overflow and you have millions of questions, all these weird problems that people cannot solve. um, so we have that experience, and I'm going to show you today uh, one example of that. Okay. uh, but first of all, let me get the screenshot. Okay, let's see. Google Chrome. So let's do a screenshot and screenshot JavaScript mod. Okay, close that. I'm going to do a screenshot here. Let's see if that's it. Yeah. So I'm gonna try that and go here. Yeah, forget about the screenshot. I'm just going to show you. Okay, I delete this screenshot. I'm just going to show you about the Lisp. Okay, so what is the issues? Let me show you. Let me drag it here. So what is the problem? The problem is in SVG. SVG allows you to draw graphics in HTML. Basically, you use JavaScript to draw graphics. For example, let me show you here. Uh, you see, you have this clock, and that is done in JavaScript, and the code is right here. It's about 100 lines, so it's not too bad. But suppose so you have a circle here. You can draw a circle easily, but suppose I want to draw a pie chart. You know, an arc of a circle. Now that turns out to be extremely difficult to do. What you have to do is, there is no. Let me show you some of the basic SVG. Okay, let's put the screen here so you can see. uh, SVG basic examples. Okay, so I need to drag it over here more. Okay, so here are some examples of how you do SVG. SVG is just a HTML, XML syntax file. So you put this, you create a HTML page, then you put this there, and you'll see a line. So basically, you have the SVG tag, saying, create the SVG tag. Then you put this, you create this line tag that says, starting point and end point, and you have a line. So this is the basics of SVG. You can learn in 5 minutes. So you have this line tag, then you have rectangle tag. To create a rectangle, then you have a circle tag. You specify, for example, you specify the center, x and y, then you specify a radius. Okay. And in the same way, you can specify a Lisp just by adding, with the radius attribute. And in the same way, you can create a polygon, text, and path, and so on. So that is the basics of SVG. It's just XML. It's just static XML, like this. You just copy and paste this into a file and show in browser, and it'll create a image, a graphics. Now, however, you see, so these are the primitives. What you might call graphics primitives. You have rectangle, line, circle, ellipse, polygon, text, and path. That's basically it. Okay, and but however, what if you want to draw an arc of a circle? Like a pie chart. Like an arc. Uh, a quarter of a circle or half of a circle. And what you have to do for that is you have to use this path primitive, the path element, path tag. So this path tag is very powerful and general, and it's fairly complicated to understand. So I would say it's actually not good, not well designed. Because it's rather extremely complex. So what you do is you specify this path and give a attribute D. Now D essentially is a list of points. Okay, D means data. Yeah. So you can see this. To create this zigzag, the syntax for the path is that. Okay, it means starting at 0, 0, then draw a line to 50, 0, which is the coordinate. Then draw a line to 0, 50, which is here, then draw a line to 90, 90, which is here. So we have a zigzag. Then path, stroke style, and so there are some variations, such as how do you not draw from some point to some point, creating a gap, or how do you close the gap from the last point to the first point, things like that. But also, path is also powerful in that it can draw curves like that. So one of the use of path is to draw elliptical arc like this, shown in this page. And the way you do that is you use the A syntax. When you have a capital A, that means that section of the parameters for the data attribute are parameters for drawing a ellipse. but this is extremely complicated. So you can read, the parameter, the meaning of the parameters here. They are very complicated. I'm not to go over them, but what I'm saying is that good morning, George. Good morning from to Australia. What I'm saying is that so to create a part of a circle, an arc of a circle, there is no option except to use this path element. And the path element's parameters are defined in such a way it's totally incomprehensible. It's like incredibly uh, bizarre. So let me actually explain what this path means. Okay. Okay. So this parameter. So you start with an A. A means the rest. 1, 2, 3, 4, 5, 6. The rest. Six numbers following A are the parameters for the ELISP. And the first two is Rx, Ry. The first two numbers means the major radius and minor radius of an ELISP. So first of all, so what does that mean? Well, to understand that, you have to understand about ELISP a little bit. So here we have so here is an example of ELISP. So from here to here, from here to here, this length is the major axis, and the shorter axis is the minor axis. So basically, to specify an ELISP, you have two parameters. One is the length of the major axis or semi-major axis, and the other one is the shorter uh, semi-minor axis. That's what it's called. So basically, you have two radiuses. Good morning, Isaac. Yeah, early today. So I'm going to talk about this extremely convoluted, bizarre thing about how to draw a arc, a circular arc in SVG. And the reason I'm talking about that is because this is an example of the extreme idiotic. I mean, there's no excuse for it. This is an example of the extreme idiocy in tech standards, in software standards, protocol standards that we have. For some reason, so this is an example. Let me finish explaining that. So 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 to specify a ELISP mathematically, basically you just have like two radiuses. You specify the center, the location of the center, and two radius for the ELISP, major axis and minor axis. Okay, that's one way. That's one of the simple way to specify an ELISP. That's a intuitive and simple way. There are many other ways to specify an ELISP. Um, but we are not going to that. Going to go into that. Uh, so back to the SVG. So the way the SVG specify an ELISP is by using the path element. And the way that works is that you write capital A with 1, 2, 3, 4, one with seven numbers following that. 1, 2, 3, 4, 5, 6, 7. Yeah, seven numbers following that. So the first two numbers are the major and minor axis. The radius, the distance. Okay. The third element is rotate. It's a degree. How much you want the whole thing to be rotated. Okay. Then you have two flags. Kind of called flags. They are large arc flag and sweep arc flag. Sweep flag. They are extremely complicated to understand. They are not, by the way, they are not used anywhere in math. Okay, they are just created by these programmers. Okay, so what are they? What are these large arc flag and sweep flag? Um, Both of them should be values of 1 or 0. Okay, so they just indicate kind of like, two options, 1 or 0. And what they are is actually, let me show you. It's like this. Uh, you see, they specify four of the possibilities of which part of the ellipse to draw from a starting point to the end point. Okay. Now, but how exactly? What does it mean exactly? It's very complicated. Okay, but I'm going to explain. Let me go back here. So SVG. So you have these parameters. Okay, flags, two flags. Then you have XY. The last two numbers means the point you want, the end point you want to finish the drawing to. Okay, so let me repeat. So Lisp, you have like seven numbers to as parameters. The first two number is the major and minor axis. Then you have a rotation, which is how much you want to rotate. Then you have two numbers for flag. Then you have two numbers for the last point to draw. Now, what about the starting point? The starting point is basically where the current point is. When you have a path, for example, in this path, we began at this point, 050. So, at this point, 1050. So 1050 is this point right here. So that's not the starting point, is not part of the Lisp parameter. So anyway, you start at the current point, whatever that is, before the Lisp parameter. Then you have these seven numbers to specify the Lisp. Now you see, so here is an example, and here is the other examples. These are examples showing rotation and more variations. But now the problem is, if you want to draw, let's say, a quarter of a circle, like this clock from 12 o'clock to 3 o'clock, a quarter of a circle. Okay, how do you do that? Basically, it's you cannot do that, because first of all, there is no primitive that just specify a circle, a part of a circle. There is a primitive to specify a circle. For example, like that. You say circle, then you say the center, cx and cy, and you say a radius. But however, there is no attribute for how much you want to draw. You can just only draw the whole circle. So but you want to draw part of a circle, like a quarter of a circle. So how do you do that? The only way to do that is to um, use the elliptical arc. So suppose you want to draw a circle from 12 o'clock to 3 o'clock. Okay? And the only way to do that is to use the path with the elliptical arc parameters. Okay? But how do you specify the parameters? Like what numbers do you put them? That is the problem. That is the question. Drawing part of the circle is extremely common. For example, in a pie chart, one of the most useful thing in graphics is pie chart. One of the most common. But however, so you want to draw that, but how do you do that? That is the question, and the solution is basically it's impossible to figure out. I mean, you have to almost be a mathematician. So that is the problem. Okay, that is the problem I'm talking about. You might try it. All you have to do, like I showed before, all you have to do is you copy You copy this into copy paste into a file and show in browser. Then you try to put the path element. Try to experiment. I guarantee you that you are going to spend several hours to to draw a arc of a circle, and that's the problem. And unless you go to Stack Overflow, in fact, you're gonna spend an hour just to read Stack Overflow solutions. So that is a problem. So the situation is that we have a common needed thing, drawing part of the circle. But however, in this technology, SVG technology, it is almost like impossible. It is almost impossible. So, so do you guys get what I'm saying? So this situation is almost impossible. Now I'm going to show you almost impossible. Okay, so this is a extreme idiocy. Like, and this is one example. This is one concrete example. So I'm going to show you next how the specification, how they talked about this issue. Uh, so here is the spec. Hold on a second. Let me turn on. Oh, yeah, let's go to their website. SVG spec. So we're going to go to SVG spec and basic types and interface. These specifications are extremely convoluted. The way, the style they write it, it's impossible to read. And it is not because it is actually difficult, nor is it because it's written for implementers. Those browsers, who need to implement this. It's not because of that. It's really just because they are extremely convoluted, because corporations and the standard body made it that way, almost like intentionally. This extremely impossible to read. Try to read it. You try it. For example, you try, you can try to read my SVG tutorial. You spend an hour, and you can pretty much understand how to work with this. Then you try to read the SVG spec. It's going to take you a month, even a month. Yeah, it's going to take you full time a month, and you cannot understand it. That's the way they are. And what I'm saying about this is that it's not necessarily it's not that way because it's necessary. It's that way because many of the social reasons. There are corporations and standard body, they are there because of money, for no reason other than money. They are usually a non-profit organization, but it's not what it seems. So anyway, so the point I'm trying to make here is about all these documentations from, the specifications from the standard body. They are extremely badly written. So that's a digression into another point. But let's get back to the ELISP to draw an arc. So let me show you. So document structure, DOM interface, styling. Uh, SVG DOM overview. DOM interface. Okay, DOM interface. Basic data types. Rendering model. Document structure. Geometric properties, coordinate systems. My God, where is it? Okay, finally. Okay, so finally they are here. So here are the basic shapes, and here is the path element. Okay, path element is what we want. And here we have elliptical arc curve commands. Okay, so here is the spec for the elisp parameters we were talking about. You see this SVG2, so SVG2 came out about last year or 2 years ago. The SVG1 or 1.1 came out about 20 years ago. It didn't catch on because the Flash, the Macromedia, Adobe Flash, they took over the industry. Those are commercial uh, technology, but the Flash got killed by Apple beginning around 2006 or so because of the iPhone. Steve Jobs basically banned it on iPhone, so that's subsequently killed it. So Flash, the Flash technology is gone. Flash technology is basically 2D drawings, pretty much like SVG. So since Flash was killed beginning around 2008, so SVG revived. So today, we use SVG. So SVG version 2 came out about last year, finalized, uh, and we are looking at SVG 2 right now. And you can see they have a comment here, annotation, SVG 2 requirement. Make it simpler to draw arcs in SVG path syntax. So you see, they actually realized this is a problem. But however, they did not provide a solution. You know, I didn't read this page thoroughly yet, but anyway, the way they don't have a solution so far. It's actually only just a note, draft. Okay, draft November 2011. Um, and this page is basically chat among the SVG standard writers. They just chat about it. So they have a notice about make it simpler to draw an arc in SVG path syntax, but it's not done. We don't have that yet. But anyway, let's go back to the thing I want to show you on this page is that they actually have a section that talks about how do you convert parameters. Let me show you where. The grammar path data. These extremely idiotic writings. Implementation notes. Okay, so it's somewhere here. So I'm going to show you, wait, where is it? So view example. Okay, so I'm going to show you a section in this spec where they talked about how do you convert an ELISP from the parameters of a center and major minor axis to the parameters used by the path syntax. Okay, here you see there is this note here. The implementation notes appendix has relevant formulae for software that needs to convert SVG arc notation to a format that uses center points and arc sweeps. Extreme idiocy. So here it is. It's an appendix B2. Um, so what's going on here? Oh, okay. So here it is. So on this page, so here they show you. They talk about the mathematical formula where, for example, normally when we, in math, in anywhere, when we talk about ELISP, we specify it by the center and the major and minor axis. You know, then then possibly a rotation. You rotate the whole ELISP, and also the parameters to specify the starting point and end point, like how much of a sweep you want, or it can be specified in as a degree. That's how people think of ELISP. That's how you specify it. But however, the SVG way of specifying ELISP is you have these, you know, sweep, large arc flag, sweep flag, and XY is the endpoint. So you basically you specify it by a starting point and end point, and with these, uh, two Boolean values for which part it is. So hi Andrew. Uh, so anyway, so on this specification page, they are trying to explain how do you convert from one set of parameters to the other. Okay. So if you are a programmer, if you are going to draw a pie chart, if you are going to create SVG graphics, you need arc of a circle. Then you need to know this formula. What you do is you look at this formula and you write a function that tries to convert it. There's no way around it because it is impossible to, like it's impossible to understand to directly specify an arc, by these path parameters. So anyway, that is the situation, and let me show you something else. The point I'm showing you. So anyway, in this appendix B, they talk about how to convert one to the other. But what is the point? I mean, you see, this is such a common need. When you design the SVG, you do not design. It's like nobody ever. No mathematicians. This the way they define ELISP by this parameter of using the starting point and end point and these flags, that does not happen in anywhere. I don't think it happens in history. I mean, if you take a survey, okay, suppose if you are God and you look at all literatures, textbooks on Lisp, all the math books, you will not find one instance. I don't think you will find one instance where they specify Lisp by this way, by this SVG way. You have a starting point, you have end point, and you have these two Boolean flags. Then you have a rotation. You will not find it. So this is a extreme idiocy. I like I work in programming industry. I have looked at a lot of technologies. Lots of protocols, computer languages, and it's fairly common to find this kind of very strange, impossible things. This is simply idiotic things. And I began to understand the way they are that way is just because corporations, they are not based on design. I mean, it's not like some programmers sit there and they think about design and they come up with this way, or maybe they come up with a way that's bad, by mistake. No, it's not like that. That's what we normally think. How these standards or specification came about. But I realized in the past few years that's not the case. The way this standardized spec came about is mostly due to social reasons like corporate struggles and incompetence and basically irrelevance and of these designers. So hi Andrew, George, and Isaac. So hi guys. So if you want me to, just post your comments. If you want me to talk about anything, just say it. Any opinions or questions or anything I'm talking about or anything else, about keyboards or anything. So anyway, back to Elise. So I'm showing you an example, and look at this. The paragraph they try to explain it. They say, look at the way the reason, the pretext, the excuse they give. They say here about why they design the Elise the way they are. Okay, let's see what they say. So they say, to be consistent with other path segment notation, arcs in SVG paths are defined in terms of start and end points on the curve. Okay, this parameterization of elliptical arcs will be referred to as endpoint parameterization. One of the advantages of endpoint parameterization is that it permits a consistent path syntax in which all path commands end in the coordinates of the new current point. However, this is not the only way of describing arc geometry used in software or mathematics. This section describes the alternative center parameterization and how to convert it from and to SVG endpoint parameterization. So the reason the SVG Lisp is defined that way is because it's more consistent with the path, the path parameters, the way the path element is defined. That's I think that's not true. I think that's a lie. I think this paragraph is not a true history. Is I don't know for sure because I have not digged into the history of who, like, which fuckhead originally, exactly what is the history. How did the SVG path element came about? Who is the first person who created this? I have not looked into that. And also in my past experience, it's almost impossible. It's extremely difficult to find how things are in the beginning. It's like a research task for a month, something like that, for a week or weeks. So I don't know what's the true history, but I do have a sense of why. Because of my experiences in researching this kind of thing. And from my experience, I think this paragraph is just lie. It's not true. It just, someone, working on the standard, they just write, they just think, they just came up with a, excuse, that seems logically reasonable. But I don't think that is true. So that's one thing. And also, they say that, look at the way they say it. However, this is not the only way of describing arc geometry used in software or mathematics. That's completely idiotic. That indicates, the above paragraph is just a lie. You know, because they say, however, this is not the only way of describing arc geometry used in software or math. What the fuck does that mean? Because in math, I can tell you off, directly, the way you describe ellipse, ellipse by starting point, end point, and arc, that does not exist. Okay, now, basically, if you look at, like you look at all the math textbooks, that almost doesn't exist. I mean, it's possible to find, one such instance, like one in 10,000 textbooks. You might find it, but it's practically never exist. No mathematician describes ellipse in that way. Um, but however, look at the way they say it. However, this is not the only way of something. It seems to imply that, you know both way are common. They are they are saying this is not the only way. They are the other way. It's a fucking, it's false. That's not the only way. It's, the way you are doing it. It's like it doesn't exist. You yourself, the SVG spec, cooked it up. Nobody ever did it, does it. So anyway, that is about this Elise thing. I hope I conveyed my my opinion about this. So in summary, let me just summarize it. Uh, let me just summarize this what I'm talking about today. So one is that I showed you how to create a circular arc or elliptical arc in SVG. Okay, I talked about, I give you a basic introduction to SVG. So that's one thing. The other thing is how convoluted is the way to draw an elliptical arc in SVG. Okay. The third thing is that this SVG spec uh, is in fact extremely idiotic, and it reflects, um, it is actually a common industrial phenomenon in programming where the standard spec or protocols, they are out of touch with reality. They have nothing to do with, they are not actually like designed by a programmer. They are a result of some kind of corporate struggle and evolution. Um, that's why we have this bunch of garbage. Okay, yeah, that's what I'm saying about that topic today. So Andrew Lee says, in university right now, how do I get the most out of it to be a good programmer instead of just another code monkey? That's a very broad question. Like, that's a very broad question. Like, depending on who you are, like where are you in university, in USA or elsewhere? And so I suppose you are majoring in programming, like computer science. And also, uh, what year are you in university? Like a freshman, first year, second year, third year, fourth year? So okay, so let me just make a general comment. Okay, oh, computer science in Australia. Okay, um, here's what I recommend. Okay, it actually depends on people, on you, on people, because I can, it's hard to give a generic recommendation or guide to people when you don't know the people, because people differ a lot. I mean, like, I have no idea what you look like, what's your background, your family, your age, even, because it's different. For example, if you are 30 years old and you are in college to maybe pick up computer science, pick up a degree, and it's also, different from if you are, say, 18 or 20, in university, and also depends on your background. So it's hard to make a generalized recommendation. But here's what some general tips. Okay, I think if you want to be a programmer, if being a professional programmer, make money by programming is your goal, if that's what you want to be, which is a very good goal. I recommend that, goal to be a programmer in a job, and that earns you money. A programmer is a good job. It's also has a future. In the next 10 years or 20 years, it's a very good job. Okay, so that's a good thing to do. To be a programmer, and so first of all, you might do that. So, but then I actually do not recommend going into a university to do that. It depends on people, of course. But if you have any inclination, if you have what it takes, I mean, if you are the type who can study on your own, for example, because you are very interested in programming, in computers, or maybe video games, you stick on with computers all day. If you are that type and you have no problem learning about the new programming language, then if you are that type, then I do not recommend you go to university at all. Don't go there. Instead, try, maybe possibly find an internship at some company, or something. Get some little, even a small pay for half a year. Okay, then just switch jobs and talk. Negotiate. Negotiate is a key. Talk and switch job and get a lot more money, like twice. Like, you know after a year, Google will hire you if you are really interested in programming. You can do it. Just learn it by yourself. After a year or two, Google will hire you even as an intern. Even as an intern, you earn a lot of money at Google, for example. I mean, not just Google, but Facebook, Microsoft. They are endless, jobs, for you. The key point is is about negotiating your salary, and be confident. I mean, I'm talking about, it depends on you, of course, depending on the person. For example, I'm a nerd, and most nerd people are not so good at, when doing interviews. You talk, you are not confident, and maybe you think you are not great, so you don't ask for much money. So that's an issue, but you can work on that. So, but basically, don't be afraid. Just be yourself. That's really a good, and ask big money for it. Ask more than what you would expect. That's and stick with it. It's not like, oh, maybe I'm not good. Really, from my experience, you just you know like, pretend for a moment when you are doing interviews. Pretend for a moment that you are salesman. You are this smooth talking salesman. Forget about everything else. You just talk fancy talks. But meanwhile, be yourself. That's an important key. Be yourself, meaning, you stick with, you just go there and say, "Hi, I'm a nerd." If you feel like that, just say that. I'm a nerd. I know these things, but no, I think I should have, 10,000, $20,000, something. Just yeah, yeah. Be confident. Be confident. That's what you have to do. Of course, the exactly what to say and how it applies. What do you mean by confident? That's up to each person. So I don't know what you are like. So I don't know if that applies. But anyway, so I recommend to be a programmer as a profession. I do recommend that. You know, and also eventually, after 10 years, you might open your own company. It'll happen if so a programmer, I recommend doing that, a professional programmer. And uh, and I do not actually recommend going to college for it. For a programmer, you can do it, and you can do it more efficiently than going to a college if you are the type that you are interested in programming, you are interested in computers, and you don't really have a problem learning stuff on your own. you know but if you are the type who, you know, like most people who prefer to have social interaction, with other people, other students, or go to a class where you learn things together, then maybe you go to university. That's no problem with that. Uh, yeah. The other thing is that actually, if you go to university, I recommend that you study math instead instead of computer programming, because math is the thing that gets you seriously into many important thoughts. That's permanent. Math don't go away, and everything you learn in math stays. They don't go away because math theories are theories. They don't change. As opposed to computer science stuff. Like when you go to a college, university to study computer science, most of the time, or more than half of the courses you are taking, they are not actually computer science proper. They are not pure computer science. They are not theoretical computer science, as far as I know. Actually, tell me what you are learning. You know, yeah, type it out. Show me what are the classes they are teaching at university. But as far as I know, what they are teaching is like half of the courses you are learning are actually just ephemeral, like current technologies. They change, they come and go. This year is good. After 5 years, it's useless. It's kind of outdated. You know, so that's my opinion about that. So are you guys still here? George, George and Isaac and Andrew. So what's up, George? So guys, give me some feedback, George. So what you up to? Like, and how old are you? Like in general, like in your 20s, 30s, or like, do you guys like my talk show? Do you want it to be more programming stuff or non-technical stuff or non-technical stuff? So I'm drinking my energy drink. This is like Red Bull, but some nameless brand. And here is grape juice. Andrew, are you still there? So anyway, okay. Um, yeah. So what do you think? What I just said about the going to university, does that make sense to you, or does that strange? Or I mean, like yeah, there is a delay. That's yeah. There's I think 5 seconds to 10 seconds. It's quite annoying. Yeah. So I mean, tell me about the university. Like, does what I say apply to you, or does it? You know, give me some comments. Like, because I have no idea. Because this is a problem that happens often, because when you are watching me, or when you read my website, everything is clear to you, because especially if you are watching me, you see me, that conveys lots of things: my clothing, my face, it conveys my age, the way I talk. It tells you a lot of things, and you can, so a lot, you guys know me, but like but I have no idea like what you are like, like imagine Andrew, George, and Isaac. Imagine each one of you. Imagine what's the other people like. It's a blank. Like, you don't know. And I have people, who are, reading my stuff. Some of them are teenagers, and some of them are like 50 or 60 years old, who's been programming in the industry. And different people. It's like all walks of life. Very, very interesting and strange. So Andrew says, I think I will fare better in university because I work better among others. Okay. And many places in Australia won't accept less than a high degree. Oh, I see. Yeah, yeah, I suppose. So I guess that's in Australia. It's interesting. I have like people following me in Australia. Like George, you are also in Australia, right? But by the way, George and Andrew, you guys know each other? It's like, did, did you guys tell each other to follow me, or just by happenstance? So I think George is also in Australia. What city are you in? George is in Perth. Let's go look at Australia, because I always love to Google. Are you in Perth? There's a country named Perth. Google Maps. Wait, I don't want Google Maps Australia. Oh, okay. So Perth seems like a, big city, because I know actually all the people I know in Australia are from Perth. I think I knew a girl from Perth. She is amazing. Uh, let's see, Perth. Oh yeah, so the other big city is Brisbane, I guess. Brisbane and Sydney. Yeah, so let's see Google Maps. Yeah, Google Map is always just fascinating. Okay, so yeah, I think George is also in Perth. Anyway, let's see. Hold on a second. So, in over here in San Francisco Bay Area, in the Silicon Valley, where Google, Facebook, all the big companies, basically in USA, degree has not be for programming. Okay, for the programming field, degree has not become important. It has become not important over here. So you don't need a degree. Just study computer science and come to California. Actually, hey, good morning, Scott. So actually, these days, programmings are a lot of it are done remotely. So you don't even need to be, you know, you don't, you can stay in Perth and work for Google. Well, I don't know if Google. Um, anyway, a lot of companies do that. Remote working remotely. And actually, I know companies. I think quite a lot of them. All their employees are remote. Like they don't have a office. They just good morning, Scott. Yeah. So Scott gave a good recommendation. Scott says, I would say for every programming language construct made to improve abstraction, learn how it is implemented underneath. Scott is a low-level system programmer, programming in C, who has to make everything as fast as possible. Scott says otherwise, some programmers choose poorly when coding up an approach. Then be sure you know how to profile for memory and speed. Some knowledge is assembly, I think, is a must. Scott, Scott, front end programming, which is the most popular field today. They don't require to know C or assembly or anything remotely like that. Front end programming. Like they don't have to know, in fact, to know how things are implemented is a waste of time. Like they do not have to know that. But however, they need to spend their time knowing all the frameworks and libraries and stuff, npm and stuff. But assembly, I think if you study, actually you want a broad understanding of programming and practical computer science. I think assembly is essential. Like for myself, I know little about, yeah, for myself, I know very little about assembly or CPU or, C programming language. And I learned a little bit, in the past few years, and I really appreciated it because I learned, the CPU, the design of the CPU itself, the instruction architecture set, that's what they call it, is extremely complex, and it is in fact it's a science by itself. It's a science and mathematics and art by itself. It's the design of the CPU. So I don't know much about that. In fact, Scott, in fact, I do have a lot of questions in that. You know, you could tell me, you could, answer my questions. Uh, yeah. So the other thing I think is important if you are study programming is to me it's just like just do a lot of programming. Try to write, try to create projects instead of reading stuff like me. I tend to just read stuff. I think you just create projects, create a lot of projects. Uh, Hello, Aldo. So Scott says you are right for front end GUI. Yeah. Uh, oh, so you did a lot CPU design. Okay. Well, let me start just to ask you a question then, since I don't have any subject right now. So CPU, so in the past few years, we started to have GPU. Um, so, so a lot people or programs these days they try to use GPU, but basically my question is, let me just say it directly. My question is why isn't CPU designed like GPU in the first place? Is it because mostly because historical reasons? I mean, CPU, the central processing unit. Why can't they just be designed like GPU? Uh, in the first place? Is it because historical reasons? Because so far, as far as I know, the GPU design is mostly parallel. The architecture is like parallel computing. So GPUs are focused on SIMD and data number crunching. SIMD stand for what? Uh, okay, Scott says, but CPUs are optimized for the random stuff that programmers throw at it. Oh, I see. Okay, I think okay, I think that gives me some clue, but of course, I do not fully understand. Um, Let me go to a page where I have some questions about that. Oh, okay. Yeah, SIMD stand for single instruction multiple data. Single instruction multiple data. Okay, and GPUs are focused on SIMD, single instruction multiple data, number crunching. Okay. Okay. Scott, actually, I have a lot of questions to ask you. It would be very helpful to me, actually. Um, so I have some notes I wrote out when I try to study CPU stuff. And let me try to find where are they. So how are you doing, Scott? You are back in right. You are in the East Coast, right? And it's almost 12 o'clock for you. Syntax through semantic. So Scott says, imagine 512 threads of execution all operating in parallel, but in lockstep. Right, that's the GPU, right? So another question, I'll just throw random questions. So why is that? Today I think the many, we I think there is a push for parallel architecture in CPUs. For example, as far as I know, the Intel Xeon is designed for that. I mean, they start to design it for parallel computing, but it didn't really catch up. So, do you have any comments on that? Because the way we are doing it today, the compilers is trying to, you know, the compilers is actually trying to parallel code, uh, and it's doing it very inefficiently because compilers are trying to parallel sequential code, from like the C language. So that's why we have the hard bug or whatever. Let me find the my article because then I can refer to it. Oh, here. Not this one. Oh, here. Oh, only limited problems like matrices graphics are good fits for SIMD type execution. Oh, one would never design a word processor to run on a GPU. Oh, what about something like mm, what about something like wait, yeah, but there is this the I don't know about these things, so if I have my question is stupid, just say so, okay? So what about this RISC architecture and this Intel Xeon and the Sun Microsoft Spark and MIPS? I thought those are CPUs. Their instruction set is designed to be parallel, right? As opposed to the Intel x86. It's because the we Intel x86 is mostly we have that because of historical reasons. Because we need compatibility. Uh, as far as I know, therefore we have a situation that the compilers is trying to convert sequential code like C source code into some kind. They try to turn it into parallel program at the CPU level. Doing things like speculative speculative execution, doing things like that. And in turn, it creates lots of complexity and problems. One example is the bleeding hearts, that CPU bug. So what I'm saying is that as far as I know, because of the sequential, because the so let me read what Scott says. Okay, RISC is easier to implement and make it fast, higher clock rates. And when you want to break down RISC and pipeline it, then RISC is easier. But when your instructions are complex, it can be more difficult to pipeline. Okay, I don't really quite get it. By the way, Scott, do you have any recommendations for like books or some websites for people who do not know CPU or any of these GPU stuff at all? I don't know. I do not quite understand what pipelining means. I think it's breaking up instructions so that the CPU can execute something like that. Breaking, computer programming instructions into units that are the CPU units. Okay, think of car assembly line. So here is a book Scott recommends. Hennessy and Patterson. Oh, computer architecture. This book. Uh, it looks like they wrote more than one book. Computer organization and design, computer architecture. I see. Pipeline. So pipeline means while one stage is doing one operation, the next is doing the next operation, but multiple cars are in the pipeline, like in a car assembly line. Okay, right. So anyway, Scott, let me ask you a more general question. That's what I intended to ask. I mean, what I'm thinking, the impression I get is that today's CPU design or GPU or today's situation of the hardware, CPU or GPU, what I think is that they are not optimal design. I mean, in the sense that if we can start from scratch, it wouldn't be anything like what we have today. The way we have it today is mostly due to historical, you know, reasons like compatibility mostly. Is that does that is that statement somewhat, I mean, can we say that's correct or more or less or something like that or totally wrong? So x86 is messy to be sure. Okay, MIPS, ARMS, Spark are pretty clean. Scott, what about the Knuth's book? Do you recommend that? The Art of Computer Programming? Because I think that book teaches people about the CPU architecture and assembly. I mean, it teaches people about algorithms, but in terms of implementing them in a machines structure. So, do you recommend the Knuth Art of Programming book? Oh, for computer science people, they are good. Okay. So, but it's not like it's less practical than the Hennessy and Patterson, I think. By the way, Scott, do you read any online news websites, Hacker News, or anything like that? So, for those of you who don't know, Scott works for Scott is a experienced programmer, with 30 years or 40 years experience. And yeah, tell us, Scott, what do you work for? What do you work on stuff? I'm a GPU designer for Qualcomm. Snapdragon chips that go in most mobile phones. Okay, anything else? I think maybe we are done here because we've been talking for 70, 80 minutes. Uh, oh, I used to follow Hacker News. Okay. Anything else, Scott? Anything you want to say or you want to tell us, or does anyone has any other questions? If not, we're gonna close down. I'm gonna shut down. Okay, Scott says I'll treat you later. The video where hardware blew away algorithm assumptions. Okay, that would be great. Thanks. Ergo King says, Hi Xa, shall I get my UHK? Not so much for typing, but I'm nerd, so. Yeah, UHK, the ultimate hacking keyboard. That's a great keyboard. But whether you should get it, you know, and not for typing, what do you mean? I mean, it's one of the great, I would say top three, okay, something like top three great keyboard, in my opinion. Great ergonomic keyboard. Uh, so, whether you should get it, whether that's the right choice for you, that depends, but I do recommend that. Yes, it support macros, so it's great. Yeah. Ultimate hacking keyboard. Yes, I recommend it. Oh, for making music? Okay, in that case, now you might need another, extra programmable keyboard because the Ultimate Hacking keyboard, they do not have many keys. That's one of the issue. Uh, so yeah, let me talk about this keyboard for maybe 5 minutes, and that'll be it for today. So if we go to the Ultimate Hacking keyboard, it's fantastic. I have a video review. You can watch it here. But however, it does not have a full set of keys. For example, it does not have function keys. There's no function keys. If you want to press function keys such as F2, you have to hold down one of the modifier, the FN, but it's highly programmable. So anyway, one issue is that it does not have many function keys. So if you need to do a lot keyboard macros for making music, you can program lots of macros, but for each macro you will need to have key combinations, and I don't like that. I don't think that's a good thing, especially if you need to do that often. So so but the Ultimate Hacking keyboard is still a great keyboard to get. What you want to do is you want to buy separately a programmable keypad, such as this one, or this one, or even or this one. You want to buy a separate. All these are good. You want to buy a separate programmable keypad, so that gives you a whole bunch of function keys. Okay, Scott showed us the video that talks about. Let's go to it. Oops. Oops. Hold on a second. Yeah. Uh, So Scott showed us a video that shit. Check. Am I offline? No. Okay, I'm still alive. Okay. This stupid Google. Hold on a second. Let me get that. I have to wait for this. Uh, so this video, let's see. Great, I'll check this out. I think that's it for today. So Sean says I got the Ergodox and it's like learning to ride a bike again. Yeah, those keywords takes a while to learn. So Scott says I think this is the video that shows how caches have made arrays vectors often to be higher performing than linked lists. Oh, in these conditions where you would think lists would be better. That's amazing. That's a great yeah, that is a great topic for me because I had this issue with array, with Lisp, especially among Lisp programmers. They they like list, list as in linked list. But to me, linked list is just stupid. Okay, the cons, especially the Lisp cons business, the cons car cadre. I think those design in the language are idiotic to the extreme. So I have this issue about array versus versus you know linked list. I'm glad to see there's tricky issues coming up you know uh, about that. Coolertron, yeah. So anyway, that's it for today. I talked about for 90 minutes. So thank you guys for coming. So I'm gonna shut down in 10 seconds. Um, yep. Bye, Scott. Bye, guys.